Graphing inequalities. We have talked a little bit about graphing inequalities before, mostly when we did graphing linear functions, but we need to talk about them again because of what's coming next. Okay? So just as a reminder, graphing inequalities, when graphing an inequality and it has a greater than symbol, what kind of line are we going to draw? Good, a dotted line. What do you think, what kind of line are we going to draw when it's just a less than symbol? A dotted line. Because what kind of line do we draw when it's greater than or equal? A solid. And less than or equal? A solid. How are you going to tell the difference if it's dotted or solid? Whether if it's equal to or not, right? Robert says if there's a line underneath here, then I draw a solid line. If there's no line underneath here, it's got to be dotted. Is that good? Okay. What about the shading? If it's greater than, where do you think you should shade? Above. That's pretty, like when you think about it, it seems pretty obvious, right? Okay. So what about less than? Below. Greater than or equal? Above. And less than or equal? Below. So what exactly do I mean by illustration? Now, what is an illustration? It's a drawing, a picture, right? So an illustration of this kind of situation would be just a graph, an x and y axis, right? Like that. Some random line. What kind of line is this, though? It's a dotted line. So maybe like that. And where am I shading in this situation? Above. Is that clear? So what kind of illustration am I going to have for the next one? X and Y coordinate, X and Y axis. A dotted line. Shading below. X and Y axis. Solid line. Shading above. X and Y axis. Solid line. Shading below. Any questions about that? We're going to probably refer back to this several times today. Okay? So, let's talk about our objective. What do you think our objective should be for today? That was yesterday's, right? That's why I'm asking you. What do you think today's objective should be? Today I will graph linear inequalities. Okay? So what are we going to do today? Graph linear inequalities, all right? So look at problem number 1. How do I graph this? Well, it gives me some little helps right here, right? Little things to remember. What's my slope? 2 over 1. It's 2, right? But we always like to think of a slope in a fraction. What's my y-intercept? Okay, can I be picky with you for just a second? My y-intercept is 0, negative 3, isn't it? Is my y-intercept just negative 3? Nope, negative 3 is a number. A y-intercept is a point, correct? What kind of line will I have on this problem? It's less than or equal, so solid. And which way will I shade? Below. So, if my y-intercept is 0, negative 3, that's right here. Aquí. Then what do I do from my y-intercept? Rise 2, run 1, right? Rise 2, run 1. Rise 2, run 1. All the way to the edge of the graph. From my y-intercept, can I fall to? If I run backwards 1, right? Now, it's pretty clear where my line is, isn't it? What kind of a line do I have? A solid line. And where do I shade? Below. So smart. Because guess what? That one's done. What about the next one? What's my slope? Negative 2/3. What's my y-intercept? 0, 3. What kind of a line am I going to draw? A dotted. And where am I going to shade? Above. So where do I start? My beginning point, right? My B, my y-intercept. So 0, 3, which is a key. And then fall 2, run 3. Fall 2, run 3. Or can I rise 2? If I run backwards 3, right? And we already said that this is a dotted line, right? And I have to shade above? Yes, ma'am. Absolutely. Are you saying yours went this way? Okay. We have a negative 2/3 slope, which means I have to fall 2 and run 3. If I fall 2 and run backwards 3, that's a 2/3 slope. That's a positive slope, and that's not what I need. Okay, so be careful of that, please. So there's something I need you to remember that we've done before. Write the linear inequalities in slope-intercept form. Well, but when you solve an inequality, if you multiply or divide by a negative number, you must anybody remember? Flip what sign? Flip the inequality sign. Excellent. So we need to practice that. Look at number 3. We need to get it into slope-intercept form, which means we have to solve for y. Okay? So what do I do first to get everything away from y? Subtract the 10x. So what I'm left with is 5y is greater than negative 10x plus 40. Now I subtracted 10. Do I flip the sign? Only if I multiply or divide, right? Now I'm I'm dividing by 5. Oops, I'm dividing, so I should flip the sign. Why not? It's not a negative number, okay? So y is greater than negative 2x plus 8. Wait, I didn't flip the sign. I must have done something wrong. So I'm not going to flip the sign every time? Oh. What's my slope? Negative 2/1. What's my y-intercept? 0, 8. What kind of line will I draw? A dotted. And where would I shade? Above. Okay, so far? I can't combine negative 10x and 40. This one has an x. It has a variable in it, and this one does not. It's a constant. I cannot combine those two. Okay? Are you good? Are you lying? Great. Okay, we'll talk in a minute, okay? What about number 4? Subtract 3x from both sides. Negative 2y is less than or equal to, can I say this is 9x? Tell me why. Only one of them has an x. They are not like terms, right? This 12 would have to have an x, or the x of the negative 3 would have to be gone. Okay, so this is just negative 3x plus 12. Now what? Divide both sides by a negative 2. That means I'm dividing every term by a negative 2. God bless you. So I get y is, what do you mean greater than or equal? Oh, I divided by a negative number, so I have to flip my inequality sign. What's negative 3x divided by negative 2? 3 over 2x. So here's my problem. I couldn't combine my 12 and my 3x because they're unlike terms. Why can I divide 3x by 2? Because you're dividing, right? Multiplying and dividing you can do. Addition and subtraction you cannot do. Can you? You okay with that? Okay. And then 12 divided by negative 2? Negative 6. What is my slope? 3 over 2. What is my y-intercept? 0, negative 6. What kind of line do I have? A solid. And where am I shading? Questions? Turn the page. So here's what's different. Tell me what's different. There's 2, and they want me to graph them on the same graph. Okay? So we're going to start slow. Let's just graph the first one. Only graphing the first one, only paying attention to the first one. Okay, how do I graph that? Start at negative 5 on the y-axis, and then rise 3, run 1. Rise 3, run 1. Rise 3, run 1. Now, I don't have all these little things to fill in, but I can think about them, right? I just thought about my y-intercept. I just thought about my slope. What do I need to think about next? What kind of line it is. It is a solid line. And where would I shade? Be careful. There are some of you that can shade now and then shade in a minute and be perfectly fine about where the solution is. I am not one of those people. I get lost. So I'm going to tell myself where to shade. I should shade below this line. Okay? So have I done everything I needed to do with that first line? Now the second line, what do? Start up 2 on the y-axis, and then fall 1, run 2 to the right, right? Fall 1, run 2. Or rise 1 and run backwards 2, right? What kind of a line is this? Solid. And where would I shade? It's greater than, so it's above. Where is the only section on this page that is true for both equations? Just right here, right? Now, guys, even the directions say lightly shade each individual area and then go back and heavily shade. You guys know that I'm so visual. That bothers me so much. Okay? Most of you guys are absolutely going to be fine if you lightly shade both areas and then heavily shade where they are both shaded. I just can't do that. It messes with my brain. Are we okay with this so far? Okay. Ooh, number 7 must be hard. Why do I think that? Oh, because there's 3. Oh my gosh, there's so much more work. Yeah, I just need to get some Kleenex and stop crying, right? Okay, so first I have to solve for y, don't I? I have to subtract x from both sides. So I get y is less than negative x plus 3. Can I graph that? Is that hard? No. Up 3 on the y-axis. That's my y-intercept. Then fall 1, run 1. Fall 1, run 1. And I really do think it's helpful for you to put every possible dot that's on that graph, because look how clear my line is. You know exactly where my line should be, don't you? Is this a solid line or a dotted line? This is a dotted line. Should I shade above or below? Below, because it is less than, right? Okay. So now I know that nothing up here can be my answer, right? There's no possibility that any of my answer can be up there, can it? So let's graph the second line. How do I graph the second line? Up 3, rise 2, run 1. Or fall 2, run backwards 1. Right? Is this a solid line or a dotted line? Solid. And should I shade above or below? Why? Because it's less than or equal. So now what? Now this can't be a solution and that can't be part of the solution, right? Okay, how do I graph this last line? It is a straight line, and that's good, Reggie, but keep in mind that by definition lines are straight. So I'm glad you know that it's a straight line. What do you mean by straight line? It's horizontal. It crosses the y-axis at -3. So it is a horizontal line that is solid or dotted? Solid. So it's right there, right? Guys, people get to these kind of lines and they freak out. There's only one variable. What do? I freak out. Oh, okay. If there's only one variable, remember all it's doing is telling you which axis it's crossing and where. It's crossing the y-axis at -3. Okay? Do I shade above or below? Where's the only part that's true for all the system? Right there. Oh, thank you. Can you tell me a shape? Oh, a triangle. Oh my gosh. Are we good? So let's do a really hard one. I know it's easy. I'm just making you feel like it's hard, because then when you realize it's easy, then you're like, oh my gosh, this is so easy. Give me like 50 of these to do. And then I'll have to say, no, 50 is really too much. Okay? What do I have to do first? Subtract x. Negative y is less than or equal to negative x plus 4. Guys, y is solved for? Is my y solved for? No. It says negative y. What do I have to do? Divide everything by negative, and when I do that, I get y is greater than or equal to x minus 4. Right? So here's a trick question. Are you ready? Instead of dividing everything by -1, could I have multiplied everything by -1? Oh my gosh. Okay, questions? How do I graph that one? Down 4? And then? Rise 1, run 1. Rise, run, rise, run, rise, run. 1, 1. Oh, can I fall 1? If I run backwards 1, right? Is that a solid line or a dotted line? It is a solid line. And would I shade above or below? Above. Okay. So that one's done. Now what? Start at 5, so I want to start the next one, right? Start at 5 on the y-axis. Fall 2, run 1. Guys, look. Negative 2 over 1, right? Is that the same thing as 2 over negative 1? Are those two the same things? They are the same thing. Because either way, I get negative 2 out of it, right? So if I fall 2, I've already taken care of the negative, and I have to run 1. If I rise 2, I have to use the negative this time and run backwards 1. On this one, it was 3 over 1. Those are both positive numbers. But negative 3 over negative 1 is the same thing, right? So from negative 5, I rose 1, positive direction, ran 1, or rose 3, positive direction, ran 1, positive direction. I could have fallen 3 and gone backwards 1. Those are both negatives. And see how it's still on the line? You okay? Are you lying? Okay. We can talk more about that later if you still have questions. I'm okay with that. Okay? Is this a solid line or a dotted line? It's a solid line. And am I shading above or below? I'm shading below. Where is below? Is it to the left of the line or to the right of the line? Are you okay with that? That's why we're not talking about left and right. We're talking about above and below, because look, to the left of this line would be above, wouldn't it? That's why we're not talking about left and right. Okay? How do I graph this third line? It's crossing the x-axis at negative 2. Where is that? Go to negative 2 on the x-axis. Oh, it's a solid line, right? It is a vertical line and it's a solid line. And which way am I shading there? Above. Because we're talking about positive values or negative values, right? So that is to the right of it. That's the only time we really talk about left or right. And how do we graph this last line right here? I go to 3 on the y-axis. 1, 2, 3. It crosses the y-axis at 3. And it is a solid line, correct? And here am I shading above or below? Below. Where do I shade? I'm proud of you for looking for a word. I hope you know that's not a trapezoid, right? It doesn't have opposite bases that are parallel. They're up on that front desk. Are you good? But I'm glad you were searching for a word. Can we say quadrilateral? Four-sided figure is perfectly fine. Okay? Are we okay so far? When do we get out of here? We don't go when the first bell rings. We know that. Okay. Okay. Yes. Yeah, we do get out at 37. Okay? Okay, so look at number 10. Number 10 is different. How is number 10 different? It's already done. What does it ask for? The system. It's asking for the inequalities, right? The equations with the inequality symbols, right? So how do I figure out what the equation of that line is? We're going to do that line first. We're going to call it line A. We don't have to call it line A. We don't have to call it anything. I want to make sure that we're all talking about the same line. Well, I need to know its slope and its y-intercept, don't I? What's either one of those that you can tell? The slope is 2 over 1. How do you know that? So if I went down 2 and right 1, what's my slope? Negative 2 over 1, right? So y something, negative 2 over 1, or just negative 2, x, and then what's my y-intercept? Plus 2. What's this thing that goes here? First of all, it's a solid line, so it's going to be something or equal, right? Can you tell that it's shading below it? So it's less than or equal. So let's look at this second line. We'll call it line C. I don't care if you call it B. Remember I told you, it doesn't matter. I can call it Q if I wanted to. Or Frank. What's the equation of that line? And then we'll deal with the inequality part in a minute. Guys, what's the easiest thing to see? That it's a dotted line, right? So it's either going to be less than or greater than. And we know that it's shading below, so it's going to be less than. Okay? Now what's the next easiest thing to see? The y-intercept, what is it? Negative 1? So what's my slope? Rise 1, run 2, rise 1, run 2. So this way I rose 1 and ran backwards 2. So what's my slope? Negative 1/2 x minus 1. Guys, think about the skier. You remember the skier I drew for you? Is this a down slope? Is he coming down the slope here? Then that slope has to be a negative number. Is that a good way to think about it for you? Is he coming down the slope? Probably faster, right? So the number should be higher, and it is. It's a 2. Hey, guess what? We're done. Okay? So, oops, sorry, wrong page. You see these 4 right here, and then the 2 on the back. Does everybody see those? 11, 12, 13, 14, 15, 16. In a minute. Let's look at line A really quickly on this number 15. Actually, let's not look at line A. Let's look at line B. Line A is too simple. Look at line B. Okay, here's line A, here's line B. What's the easiest thing to see? It's solid, so it is, and I'm shading above it, greater than or equal. What's my slope? 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 1. So I fell 5, went left 1. So what's my slope? It should just be 5, right? Okay. So 5x, where's the y-intercept? Where does this cross the y-axis? Don't tell me there's not one. There's not one that we can see, right? So we need to use our brains. I know that leaves some of you out, okay? But if we know it crosses here. We know for sure it crosses here. If I go down 5, 1, 2, 3, 4, 5, and over 1, won't I be at the y-intercept? Well, where is that? Oh my goodness. You're going to have to do some thinking on some of these. You're going to be okay? Now, this one's good because it's only in first quadrant, but can I see the y-intercept of either of these 2 lines? No, so I'm going to have to think about it. Okay? Write this formula down at the top of the page. What formula is that? Close. It's point slope. Okay? If you know if you know a point and a slope, this will help you find the equation of the line. So if you're struggling finding the equation, especially on something like this line right here, or this line, go use that. Plug a point in that you know, plug a slope in that you know, and it'll help you find the equation. Okay? Go to the other paper, please. Here's the best part about this other page. We'll fill in the top just in a second. Okay? We'll fill in the top just in a second. But here's the best part about this page. Guess what we're going to do? The same exact thing. How do I graph this first line? Go to 4 on the y-axis. Fall 2, run 1. Fall 2, run 1. All the way to the edge of the paper, right? Both directions. So rise 2, run backwards 1. Solid line or dotted line? Solid line. And where am I shading? It's less than or equal, so I'm shading below. How do I graph this line? Start at 7 on the y-axis. The slope is 1 and it's positive, so I'm going to rise 1 and run 1. It only gives me one thing, so I've got to fall 1 and run backwards 1 to get the rest of it, don't I? Okay. Solid or dotted? Solid. Above or below? Below. Last one, I got to solve for y, don't I? Subtract x from both sides. 3y is greater than or equal to negative x minus 3. Divide everything by 3. So y is greater than or equal to negative 1/3 x minus 1. Correct? Okay. So it crosses at negative 1. Crosses the what at negative 1? The y-axis. Good. Rise 1, run backwards 3. Rise 1, run backwards 3. Or fall 1, run forward 3. Right? Solid or dotted? Solid. Am I shading above or below? It's greater than, so above, right? So where is my common area of shading? That triangle. This is what's different, right? Up to now it's exactly the same, right? This is what's different. It asks me to find a value. In fact, two values, a maximum or a minimum, and it gives me this equation. I don't graph that. There's no excuse me, there's an x and a y and a c value. I can't graph that. Okay? But what I do find is my vertices. What's a vertex? Give me one example of a vertex. 3, negative 2. Is that what you're talking about right there? 3, negative 2. So vertex is a point on the graph where they meet, right? So this one would be negative 1, 6, right? Negative 1, 6. And the last one would be where? Negative 6, 1. We okay so far? Now what I need to do is I need to plug x and y into this equation. 8 times x, which is 3, plus 11 times y, which is negative 2. Well, what is 8 times 3? 24. What's 11 times negative 2? So what's 24 minus 22? 2. C is 2 for that point. 8 times negative 1 plus 11 times 6. What is 8 times negative 1? Negative 8. What is 11 times 6? Plus 66. What is negative 8 plus 66? 58. Okay. 8 times negative 6 plus 11 times 1. What is 8 times negative 6? Negative 48. What is 11 times 1? 11. What is negative 48 and 11? Negative 37. What does it ask for? A maximum and a minimum. So tell me, which one is the maximum? 58. Now, if you don't mind, I'm going to use the letters MAX to be shortened version for maximum. Any idea what I'll use for minimum? Oh my gosh. Where does it go? Okay? Please remind me tomorrow that we did not fill in the words. We have to go fill in the words. Please do number 2. Number 2. Of course, all the other ones are extra. Otherwise, have a great day.